channel. Hi everyone, welcome to Svit channel. The subject is automotive electronics, 17EC561, the module 2 and sensor. So according to the previous video with the continuation of sensors, today we are going to learn some more sensors based on the vehicle systems. So here we take out the topic called oxygen sensor. So the question arises that what is the oxygen sensor, why it is needed in a vehicle system, and what is its importance, and what is the type of architecture we'll get it. Okay, so what is auto oxygen sensor do? Okay, the oxygen sensor measure the amount of oxygen in the exhaust gases. Okay, so as we know that the outlet of engine system is exhaust which is come out from the vehicle. Okay, the oxygen sensor measure the amount of oxygen in exhaust gases. The oxygen sensor has precisely checked this red hot exhaust 100 times per second or 100 times per minute. Okay, so every 100 times of per minute it will try to capture the information of exhaust and it will be informed to the vehicle computer or a vehicle microcontroller. Okay, and by measuring, what is the use of this, why we have to measure this one? So by measuring the amount of oxygen in exhaust, the oxygen sensor can tell if your engine is running in a lean or rich. Okay, so as I told you, the importance of this oxygen sensor is that it can detects or it gets the information of lean or rich and tells the computer to make the changes accordingly. Okay, so this is the a little bit introduction and usage and application of your oxygen sensor. So basically you can see this one, oxygen sensor works by burning some unburned oxygen in the exhaust, producing voltage which varies by the percentage of oxygen in the exhaust. So thereby telling the computer, as I told you, by thereby all the information which is collected by the sensor, it will be given for the computer system. So as you can see in the figure, this is the small diagram basically used, or a sensor wise it is used. So this is the inlet part and this is the outlet. So here you can see this part is called as a high pressure seal. Okay, and this is a outsider air. Okay, this part is nothing but the golden part which you are seeing is housing. Okay, and this particular material, the white part which you are seeing, that is called as an interior platinum electrode. Okay, and this part is nothing but your exhaust manifold, and these parts are called as a exterior platinum electrodes. So for this we are going to excite by giving a voltage. So this part red color what you are observing here, it is called as a negative. Okay, this bluish part it is called as another electrode which is connected with a positive. Okay, so by giving a power supply, this sensor will go to the on condition, and whenever the inlet exhaust of your air is coming in this direction, it will try to calculate and it will decide whether it is a rich mixture or a lean mixture. Okay, so according to the point it says that different fuels have different perfect ratios. Okay, there will be different fuels will be having a different ratios of combination. The ratio depend on the quality of carbon and hydrogen. As we know that in the exhaust we have a two parameter called carbon and a hydrogen, and in the fuel amount. Okay, if there is a less air, keep in mind, if there is a less air than this perfect ratio, okay, so the perfect ratio will be already defined by the vehicle manufacturers. Okay, so here the considering that if there is a less air than this perfect ratio, there will be a fuel left over after combustion. This is called as a rich mixture. Okay, I hope you are understanding this point. If there is a less air than this perfect ratio, there will be fuel left over after combustion. This is called as a rich mixture. A rich mixture is a bad because this unburnt fuel creates some car pollutions. Okay, so if you left with some unburnt fuel in the engine system, that may leads to the pollution. Okay, next point is a lean mixture is a cause when there is a more air than this perfect ratio. Okay, a lean mixture is caused when there is a more air, because here we are considering less air and here we are considering a more air than this perfect ratio. This is cause poor performance. So we have to keep in mind these two are very important in a vehicle systems. So based on this, the overall performance of the vehicle or a consumption of a fuel can be decided. When the oxygen sensor fails, the computer can no longer sense the air fuel ratios. Okay, so inlet of your air fuel ratio can be calculated with the help of your oxygen sensor and end up with a guessing and your vehicle run inadequately by consuming a more fuel. Okay, so this is how the utilization of an oxygen sensor and where exactly we can use this one. Okay, so here based on that, exhaust gas oxygen sensor will be also called as a lambda sensor. Okay, keep in mind it is also called as a lambda sensor. According to the definition, the amount of oxygen in the exhaust gas, the amount of oxygen in the exhaust gas is used as an indirect measurement of, okay, indirect measurement of air fuel ratio. Okay, that is given as lambda equals air slash fuel divided by air slash fuel at a stenometric measurement. Okay, stoichiometric measurement is like if you have lambda is equal to 1, air fuel at a stoichiometric measurement. If lambda is greater than 1, it will be too lean. Okay, it will be too lean. If 1 is greater than lambda, okay, the mixture will be too rich. So based on this, you are going to calculate the lean and rich of a vehicle system. Okay, so what I showed you in the previous diagram, same thing. It is as I told, this part is a sensor part. So in V2 exam, you are supposed to write this diagram. Okay, that's why it is called as a sensor mounted in a exhaust manifold. Okay, this is exhaust gas, this part is exhaust gas flowing. Okay, and this is the power supply. Okay, so inside the sensor it look like this. Okay, I hope you have understood how this oxygen sensor or a lambda sensor works in a vehicular system. That is only I have explained. Okay, so this graph represents like how rich and lean mixture it is switching over. So this part is nothing but a rich mixture and this part is nothing but a lean mixture. Same diagram, either you can write in V2 question paper this one or these diagrams. So coming to the next topic, we'll jump to the directly to the actuators. Okay, as I told in this syllabus you will be having actuators also. Let's see what is a little bit introduction about actuator. In addition to the set of sensors, electronic engine control is critically depend on a set of actuators, okay, to control air-fuel ratio, ignition and a ECR. Each of these devices will be discussed separately, okay. What happens here, an actuator is a device, okay, that receives an electrical input from a engine control system and produce a mechanical action or a thermal output. So basically, as we know that sensor is sense the environment, gives the output in the form of electrical output, whereas an actuator is a device which takes the electrical as an input or electrical signal as an input and makes a mechanical action or a thermal output. So based on that, we have a very important sensor is fuel injector, okay. So this is the solenoid valve. Just directly jump to the diagram better to understand you people, okay. How fuel will be injected into the engine system. As we know that engine inlet will be two parameters, one is air inlet, another one is a fuel inlet, okay. So but here we are considering a fuel injector. So maybe in the VTU exam they may ask you write with a neat diagram a fuel injector, okay, and explain, okay. So this is nothing but your fuel injector, okay. So what are all the parameters are there, first we will see, then the working. So this is the construction of a fuel injector, okay. For fuel injector, this part is nothing but this cubical box is nothing but a core material, okay. Ferromagnetic core material will be there, okay. For that particular metal, you are going to wind the coil, okay. Copper wire, it may be like copper wire will be winded, okay. There will be a spring action here. For the spring, you will be connecting a plunger, okay, and this part is nothing but your nozzle, okay, and these small dots which we are seeing here, it is called as a fuel, okay. Initially, let's go for the working now. This is the outer structure and this is the inner structure, okay. So when jump into the working condition, when no current is passing, so this is nothing but a I, okay, this is nothing but a I. When no current is passing through the coil, okay, what happens here, this ferromaterial, whatever it is there, ferromagnetic material, it won't generate a magnetic field. So spring will be in a normal condition, nozzle will be in the down condition, okay, it is nothing but like a off condition, and whatever the fuel it is coming in this direction either or in this direction, it will be not flowing into the engine system, okay. So if we consider in this direction, okay, so this part will be going to the engine, okay. So what happens, there will be a nozzle, the nozzle will be in closed condition, whatever the fuel it is there, it will be filtered here itself, okay. Whenever the current is passed, okay, whenever a current is passed, what happens, the current will start to flow in this coil, okay. During that time, a magnetic field will be generated that makes the spring to bring it to the upper direction, okay, and try to fetch upper direction. During that time, whatever the plunger is there, it will try to open up. So whatever the pressure of fuel it is there, it will try to pass it through the nozzle and it will go to the engine system, okay. So this is how a fuel injector can be controlled through your controllers, okay. I hope you have understood what is the concept of fuel injector and what are all the things they have used, okay. A simple logic it is being used here, okay. What happens, if you take a small coil, an inductor, and pass it with a voltage, here, positive and a minus, okay. If your voltage is 0, here the voltage is 0, what happens, the coil will be not energized, the current will be 0 at this direction, Okay, current will be 0 on this direction. But when we apply a V is equal to around 2.5 volts to 5 volts, let me take as a 5 volts. Okay, what happens? The current will start to flow through the coil. Okay, there will be around the coil, the EMF will be generated. Okay, so whenever I take a small piece of iron toward this one, it will try to attract. So it uses a Coulomb second law. Okay, it uses a Coulomb second law. So same concept is being used here. Okay, so this is how the fuel injector can be controlled. That is only in the form of theory it is being explained here. So this is overall small model. That same thing I have explained over there. Whenever the coil is de-energized, okay, coil is 0, that time what happens? The momentum of this movable steel will be in the off condition. It won't move. Whenever the coil is energized, what happens? It try to pull downwards. Okay, that time what happens? Whatever the fuel pressure it is there, it will go into the engine systems. Okay, so this is how the concept of fuel injector works in a vehicular system. Okay, this is the last topic in this particular module. Okay, thank you very much.